Hey everybody, it's Gio from Microsoft at Florida International University, and today is January 23rd, 2014. It's 11:21 a.m. and in this video, I'm going to show you how to use the power meter technique. So the power meter involves a bar that's red, and it's going to be overlapped by a green bar. Now that green bar will get longer and longer depending on how long I hold down my button, which is this red square. And then this thing on the left is my power count, which is going to have a number to keep track of how much power I have at the moment. So I'm going to do a quick layout run, show you exactly what's going on so you'll understand what I'm talking about, and then I'm going to get into it. So here's my number, right? Here's my bar, and here's my button. I click the button and my power meter goes up until it reaches its limit, and then I let go and it goes back to 0. So that's generally how a power meter works, and you may notice this looks something like a life bar from a video game. I'm pretty sure if you reverse engineer this example, you'd easily be able to make a life bar. I may even add a life bar in a techniques video in the future. Just lay it down in the comments section if you're interested in seeing a life bar. But going back to this, I'm going to show you how I do the power meter. So I have 3 groups: initialization, updates, and power meter. And I have a global variable called power. So this global variable pretty much just keeps track of what my value for my power is. So the power is the green thing that's spreading across that red bar, and it gets bigger and bigger. So on the start of the layout, I just reset globals because whenever you're using globals, you have to account for them. Since globals do not reset when you switch layouts, you have to think of how you're going to make sure that they do what they need to do every single time. Alright, so let me minimize the initialization, and going into updates, we do something a little more complicated, so I'll handle that later, right? But right now, let's start with power meter. So, you have a big red button, which is the green square, the red square, and you have basically power. So what I do is, I check with my touch object, I check, is the player touching the big red button? And if the player is touching the big red button, I do a second check, and I say, is the power less than 100? So if the power is less than 100 and the player is touching the big red button, then I set the animation frame of the big red button to 1. So let me show you what's going on with that, right? I have 2 animations, a red and a blue. My button turns blue if you're touching it, and it's red if you're not touching it. So that's what that second frame's for. I set the frame to 1, which turns it blue as I'm touching it, so I know that I'm touching it, right? And it also sets the power to itself plus 1. So this is kind of like incrementing, right? And then when I'm not touching the big red button, then I just set the power to 0. And I set the animation frame to 0. Now, it may actually be possible to just do an else here. I could just probably do an else and that would work. But I just did it this way to be safe, because you don't know what may become true or untrue depending on the conditions as you build this out into a larger project. So when I'm not touching the button, I set the power to 0, I set the frame to 0. So as you'll see, the 0 frame is the red one, the 1 frame is the blue one. So that is ideally how it works. Now, the real trick comes in the updates, because I have my green bar, and this green bar is just a square, right? And I actually set its width to 0. If you notice, its size is 0 by 32. It has a width of 0, and every single tick, I'm going to set its width to this value. So all this value is it's some function that I created in order to keep track of whenever I'm clicking the power meter. So all it does is it sets it to 544, which is the maximum size of the bar. Like this red bar is 544 if you look at it. So all it does is once I go 544 times, and then I multiply it by power divided by the maximum, the maximum number power should have. So in this case, it's 100. And you can change that. And this may be a little complicated, so I'm going to put the project in the SkyDrive so you can go over it if you don't understand it completely. And this math function just works like this. I go, 544, which is the length of the the red jump bar. Or I could probably just say jump bar red dot width. That'll actually be the same thing as saying 544. And then I can say times my power divided by whatever my power should go to at maximum. So maybe I have something called a power limit, which I could, I could go declare another variable if I want and just replace this stuff. But for now, I just put it at 100. So when I do this, I say my power is going to be limited to 100, right? So let's say I wanted to change that to 500, right? Now, it would actually be different, but I would have to also make sure that this corresponds to it. So it would also work the same way, like this, and I'll show you right now. Right, I'm gonna run it, and it's gonna take a bit longer to get to my full power, but it'll still work the same way. Now my power meter just goes to 500 instead of 100, and that way you can kind of create your own sensitivity as to how powerful your button press is, or how long you have to hold it. And I'm sure you can create a series of game ideas and awesome projects just based off of this. So I hope you guys have a great day, and I'll see you in the next video. Don't forget to rate, comment, and subscribe. Thank you.